This is the second part of podcast 5 or Unit 5 forces, and this is about density. So what is density? Density is a property of a material, and density depends on the mass of the material and the volume of the material. So we calculate density using the equation, the mass of a material divided by the volume. So mass can be measured in kilograms or grams, and volume can be measured in meters cubed or centimeters cubed. And those are the normal units that we use: kilograms per meters cubed or grams per centimeters cubed. Now, density is a property that doesn't change. So it doesn't matter how much of the material you have, the density is always the mass of it divided by the volume. Excuse me. Calculating density. Right. The formula for density is mass divided by volume. And so we write down, now the symbol we use for density is something called rho, and it's like a P. You can either use a capital D or a P. We'll just use a capital D. So we shorten that to density is mass over volume. Volume is usually a capital V. So density equals mass over volume. The mass is 96 grams. The volume is 12 centimetres cubed. And that gives you an answer of 8. And we always write the unit in. So because this is in grams and this is in centimetres cubed, we're dividing grams by centimetres cubed. What is a mass of 5 metres cubed of cement, which has a density of 3,000 kilograms per metre cubed? Again, you can stop the podcast at any time and try out these questions yourself. So we'll have to give this a wee go. Write down the equation. Now we need to find mass, so we need to rearrange this equation. And to rearrange this equation, you must multiply both sides by V. And when you do that, the V's on this side cancel out. So you get V times D is equal to M. And so we'll put the numbers in. V is 5. D is 3,000 kilograms per metres cubed, and that's equal to M. So M is 5 times 3, which is 15,000 kilograms. And that's your answer. Now, next question asks you to calculate mass of air. And they give you dimensions of a room, but they don't actually give you the volume. So the first thing you have to get is a volume. So volume is length by breadth by height, which is 10 by 5 by 2. So 10 fives are 50 times 2 is 100, and that's metres cubed. Then it says the density of the air is 1.3. So again, density is mass over volume. We need mass, so we're rearranging the equation the same as the last question, and it becomes density times volume, which is 1.3 multiplied by 100, and the mass 100 times 1.3 is 130. And again, it's measured in kilograms, and we know that because we were given the density in kilograms per metre cubed. Now, explain why a ship made of steel is able to float in water, even though steel is denser than water. So, objects float because they are less dense. That's why wood floats in water. Wood is less dense than water. How can a big steel ship, which has a much, much higher density than water, float in it? And the reason is because inside that there's an awful lot of air. So even though the density of the steel is much greater than that than the water, because there's so much air in it, that gives it a much, much lower average density. So average density of the ship is less than the density of water. We're going to write seawater actually. And then objects which are less dense than their surroundings float. So you might have an object which won't float in water, but it will float in another liquid like oil or something like that. And the reason is because because it's denser than water, it sinks, but if it's less dense than another liquid, it will float. Now, the last wee bit then is how do you find the densities? And this is a very common question of different materials. And it really depends on the shape or the type of material that you're trying to find the density of, how you go about it. So if you have a regular solid like this piece of metal here, all you need to do is write down your equation, density is mass over volume, and explain to the examiner how do you find the mass. So how would you find the mass of that? You put it on a top band balance. And weigh it. And then how do you find its volume? To find its volume, you're going to have to measure its length, its breadth, and its height, and just multiply them. So volume equals length by breadth by height. And then the last thing you would explain is that you calculate density using mass over volume. So it's very straightforward, the density of a regular solid. Now, an irregular solid is a bit more complicated, and the problem is we have no easy way of measuring the volume. So again, write down density is mass over volume. Mass is easy, and to measure the mass all you use is a top hand balance. Just set, there's a stone in here, so just set the stone in the top hand balance. Volume's a bit more difficult, and there's two ways of doing it. If it's a small object, attach it with a string, fill up a graduated cylinder with some water to a certain height which you know the height of, place your stone in, and the stone will displace its own volume of water. It's called displacement. And so you calculate the difference between the original volume and the new volume. And in this case, you may not be able to see it, but originally it was sitting there at 30, and now it's up at 40. So you explain how to get the volume using a displacement technique. And so either use a measuring cylinder if the object's small enough, or if it's too big, we can use what's called a Eureka can, where you fill your Eureka can up to just below the spout with water. You place your object in, place it into the water, and have a measuring cylinder here collecting the water that drops out. And then all you have to do is pour that into a measuring cylinder and get the volume of it. So you explain that using a displacement technique. So again, density equals mass over volume. Explain that at the end. Right, the last one then is density of a liquid. And a liquid's difficult because, yes, we can easily find its volume this time, but it's difficult to find its mass. So we'll write down volume. So you're going to use a measuring cylinder or graduated cylinder. And if they were very fussy about it, remember from all your science that you have to measure to the bottom of the meniscus there. But it probably won't be as fussy about that. You're just explaining you get volume using a measuring cylinder, and then the other problem is mass. Now, what you have to do is take a beaker, put your beaker in the top pan balance and weigh it, pour in your liquid into the beaker, and then weigh the beaker again. So you weigh beaker empty, then you weigh beaker and water or and liquid, and the difference between them, I'll write this up here, the difference between them equals the mass of water. And then don't forget to explain, then you use your equation, density is mass divided by volume.